Okie dokie, let's start with the properties of logarithms. All right, so we're just going to talk about properties. We're going to do a few examples and then we'll call it the end of the lecture. So what are the properties that we're talking about? So some of the properties, one is called the product rule. Whoa. The product rule. So the product rule states that if you have the log base A of m times n, that can simplify to log base A of m plus log base A of n. Now don't forget, this can also go backwards. So you have two logs with the same base. You can combine them. And when you add them, you will be multiplying the m and the n. Okay? We have the quotient rule. Quotient rule. And I think you can already guess what this is going to be. So log base A of m divided by n can be simplified to log base A of m minus log base A of n. And last but not least, the third rule is called the power rule. And the power rule says if I have log base A of m raised to the p power, right? That's going to simplify to the power times the log base A of m. So again, these do go backwards. So that's what you're going to be able to have to do. So some of the examples, here we go. Let's start with example 1. So what are you going to have to do? You're going to be given a problem that is going to say, for example, log base 5 of the square root of x divided by 25y to the third. Okay? So what we would have to do is we're going to have to simplify this as this. We know that because it's dividing, we would subtract. So I got log base 5 of the square root of x. Let me see here. Minus. Now what I'm going to do here is notice that the bottom is multiplication. That would be adding, and that's why I'm putting the parentheses there, is because if we did order operations, I would have to multiply the 25 and the y cubed first before taking the square root of x divided by the product of the 25 times y cubed. So this would be the log base 5 of 25 plus log base 5 of y cubed. All right. So let me see here. Maybe this will help as well. If I maybe highlight that piece and change it to red just so you can see how that became red, and leave the other part as the black. All right. So from there, we need to change, some of these already have powers, but that square root is going to kind of throw me off here. So let's change everything to powers, okay? So this is going to be log base 5 of x to the 1/2, because I can write radicals as rational exponents, all right? Minus. Now, this is going to be log base 5. So one of the things I'm going to do here is because 25 can be written as an exponent with exponents, which would be, let me change this here to 5 squared plus log of 5 y cubed. So let me do this here. So I'm taking this 25 and I'm changing it to 5 squared. So you see where that number comes from. All right. So with that being said, I can write this way. This is now equal to 1/2 log base 5 of x minus 2 log base 5 of 5 plus plus 3 log base 5 of y. Okay, so let me do this here just so you can see. Let's how do I want to do this? Let's change this to this color just so you see where the 2 is coming from. Let's take this 3 and let's change it to a different color like blue, and change this 3 also to the color blue, and then let's change this color here to green, and also change this 1/2 to green as well. All right, so now you can see where those powers are coming from, and I'm just using the rules, the power rule there for that. All right, so what's next? Oops. So the question is, what's next? So what's next is going to be this. I want you to notice this right there. Actually, better yet, let me do it this way. I want you to notice this right there. So log base 5 of 5. Now, if you go back to 4.2, what we said was if the base 5 and 5 is exactly the same. So let me write down the rule here. So I know that this rule is if I have the log base 5, better yet, I'll do it this way. Log base n of n, that is going to equal to 1. Okay, so that is from 4.2. All right, with that being said, let's rewrite this whole thing correctly. So I got 1/2 log base 5 of x minus 2 plus 3 log base 5 of y. Okay. Now I have to distribute that negative through, so my answer is actually going to be 1/2 log base 5 of x minus 2 minus 3 log base 5 of y. So that would end up being my answer. Okay, actually let's do it this way. There we go. All right. So hopefully if you have any questions, you message me or text me or whatever you guys need to do to get some resources. All right, let's see here. I have another example here. Example is kind of opposite now, going backwards. So let's say I have 4 ln natural log of x plus 2 natural log of y minus 5 natural log of z. Okay, well, now I'm going backwards. All right, so in order operations, it's parentheses exponents, multiplication, division from left to right, and then addition, subtraction from left to right. So in other words, in this case, I would multiply, or I should say, I would add first, then I would subtract. So when I write this, number one, let's convert this first. So this is going to be ln of x raised to the fourth plus ln of y raised to the second minus ln of z raised to the fifth. Okay. All right. So again, I was saying that we're supposed to add or subtract going from left to right. All right. So in other words, really, what I have is that this right here will convert to the ln of x to the fourth times y squared minus ln of z to the fifth, which now I can say that this is equal to the ln of x to the fourth y squared all over z to the fifth. And that, ladies and gentlemen, will be my answer. So I think that this way is easier in this direction rather than in this direction, okay? So you gotta be able to go forwards and backwards, all right? And then the other part that needs to be taught is the change of base. And this is mainly used to evaluate or to simplify. So let's put down the rule first, or the property first. So what it says is, if I have the log based a of m, and I needed to evaluate this, this is equal to log of m divided by the log of a. Okay, so in this case, I'm using the base 10. All right, you can do it with any base you want, but this is probably the simplest way to go. All right, I believe this is called the natural log. All right, no, this is not the natural log. I'm sorry. This is the common log. All right, so this is using the common log. However, you can use the natural log as well. So let's say I have the same problem still, the log, log base a to the m. So if I decide to use a natural log to change the base, I'll have ln of m divided by the ln of a. And that will give me an answer as well. So for example, if I was given to find the log base 12 of 15, what I would do is I can do one of two things. I can either find the log base 10 of 15 and divide it by the log base 10 of 12. Or I can also do the natural log of 15 divided by the natural log of 12. All right. Either way you do this, you're going to get an approximate answer, right, as you type it in, is going to be 1.0898. All right. Hopefully you guys have no questions, but if you do, you know how to get a